biggest draw from energy around the world is how we heat and cool our buildings. And the creation and utilization of energy is the biggest contributor to the climate crisis. So in order to tackle the climate crisis, we need to address energy. And we need to do two things. One, we need to increase the efficiency of how we generate and use that energy. And two, we need to find alternative ways to generate energy. In this interview, we are going to focus on increasing the efficiency of how we use energy by designing systems that allow buildings to consume less energy based upon how they are designed. Madhu is the CEO and founder of Oorja Energy and Engineering, and he and his team of engineers design these systems to allow buildings to operate more efficiently and give us a chance to meet our climate goals by lowering the consumption of energy. So make sure you check out this entire interview to hear exactly how Oorja Energy is making that happen. All right, Madhu, do you mind telling us a bit about Oorja Energy and what you guys do?
Sure. Thanks for having me today. We provide sustainable cooling and heating solutions. We do that by combining close to about 15 different technologies. Our expertise is primarily in designing and, more importantly, in deploying these different solutions. We use technologies like radiant cooling or heating, geothermal heating, cooling, and then there are some proprietary solutions that we use like multi-stage cooling towers and wastewater waste cooling or condensate capture. So these are relatively new, just with few installations, but what we are aiming towards is to bring down the energy consumption by cooling systems by 50% and maybe extend it even to 90%. So we've been deploying these solutions for about 9 years, mostly in India, and we are just getting started.
That's great. And you say you're hoping to bring energy consumption down by 90%. That's impressive. How do you plan on doing that for different buildings?
So I'll go back a little bit to give a certain context. See, so
Sure.
far, the way we've been defining what cooling is, that needs to be looked at. We have somehow ended up defining cooling as 24 degrees, which is about, say, 75 Fahrenheit and 50% RH, just as what it is in the US, right? But now there is an effort to move towards what we call adaptive thermal comfort, where temperatures up to even 30 degrees or say 86 Fahrenheit are acceptable depending on the weather conditions. Because you have to realize we are in a tropical country, and if you walk out of a 24 or 22 degrees centigrade space into a 40, 42, 45 degrees, which is nearly about 115 or 120 Fahrenheit, your body experiences a thermal shock, right? So more and more buildings are, especially in the public infrastructure, what is our public infrastructure, accepting this model where we are fine with anywhere between 26 degrees, say about 78 Fahrenheit to 86 Fahrenheit, right? So when you look at that, you don't need a lot of solutions that we do, like multi-stage cooling tower, where we are using evaporative cooling in multiple stages to provide cooling without using a compressor. And if you know cooling, you know that 90% of that consumption is due to compressor. So we have come up with something called structure cooling, and structure cooling reduces energy consumption by more than 90%. Of course, it doesn't deliver the 24 degrees, 50% RH kind of comfort, but between 26 to 30 degrees centigrade, which is sufficient in many of the public buildings like our public schools or bus stations, railway stations. So what we do in this is primarily flush the heat that gets accumulated in our building concrete structure. What you have to know is, unlike US, where a lot of structures are not built out of concrete, in India we use a lot of concrete and steel, which basically absorbs heat and accumulates heat. In structure cooling, we just flush out this heat and the building becomes cooler. Therefore, it feels comfortable. Unlike what we do today is we let that heat come inside, and then we use an energy guzzling equipment like a conditioner throughout that heat. But what we are doing is now not allowing that heat or heat that accumulates in the structure, flush it out so that it never comes in. So you don't have to use air conditioning. The structure cooling solution was awarded as a winner by MIT in a worldwide contest for energy efficiency a few years ago.
Nice. That's awesome. And so how are you flushing it out? Are you using ducts and a pump to suck it out, or is it just through the way that the building is being built and the design? How is that working?
So what we do is embed a network of pipes when the building is being constructed. Right? Now, we have done some thermographic studies where we see that even in the summer here, even in the night when there is no sun, the indoor temperatures remain above 35 degrees centigrade, sometimes even up to 40 degrees centigrade, because the heat is being radiated by the walls and the roof. Because when you are inside a building, you are not exposed to the sun directly, neither are you exposed to the ambient temperature. All that you are exposed to is actually four walls, ceiling, and floor. If they are hot, then you feel that heat, right? And this is what happens typically in all tropical countries that use concrete and steel to build. Sun comes up, dumps the heat, goes away. Where does that heat go? Gets trapped in concrete structures. And that is what radiates heat to you, right? So if you flush this heat out, the temperature of the building would be same as what it is in winters here, not winters that you see there, but where the temperatures are more in the region of the building the surface temperatures indoors, which is what matters, would come down from 40, 45 degrees centigrade to 25 degrees centigrade, right? Which is about 75 Fahrenheit. And they don't act as heat sources. They act now as heat sinks. Now, traditional buildings in India used to be built with large thermal mass. The external walls used to be 2 to 3 feet thick, in some cases even 6 feet thick. And one of the reasons for that was it offered resistance to the solar radiation so that the indoor surface temperatures always remained below 30 degrees centigrade. Now that due to modern constructions, cost reduction, you have gone down to natural glazing, right? So that now become being a heat sink in the traditional construction has become a heat source, right? So what we are trying to do is mimic the way people were doing it, but now since we can't afford all that, we are now using active systems. And by the way, this is not something we have come up something new with. This has been implemented in few buildings in India which date as far back as 450 years. They've used terracotta pipes and used to send water, especially the forts where the kings needed to be comfortable. So we're just using a modern way now to do. We just flush out the heat from the building, it'll take care of itself.
Gotcha. And you mentioned structural glazing. Was that like they put something on top that was more reflective? Are you also using that like in conjunction with these, or was that something different?
It can be used, but typically that is the domain of an architect. So we let architect design the building facade. Now because it's not just thermal aspects, you need to consider the aesthetics of the building. What is the concept and how do you want to is prerogative of the architect. Now, once the architect has built that building, that's when we come in saying, hey, what is left? Whatever architect has done through passive means, we have to see what more heat is coming into the building and how do we stop that. So that is when we add these active elements. One thing to note here is that if you see most of the developed world, all these countries are above the Tropic of Cancer, right? Most of it. So you have mild summers, but we are primarily a tropical country, right? So to give you an example, let's say a 2,000 square feet residence in North Carolina, we need maybe 4 or 5 tons of cooling at best. You can correct me there, but that's my guess. But a 2,000,
that's probably right.
But a 2,000 square feet house residence in Mumbai, say, would require nothing less than 10 tons of cooling. Our specific loads are higher, and we use cooling for more number of hours in a year, at least 3 to 4 times more. So if we don't find a way to do this differently, which reduces significant energy consumption, we cannot provide cooling to this entire nation of 1.3 billion, which is growing and being more affluent. And that is one sign. And cooling, access to cooling becomes an aspirational need at some point where everybody wants to have it. We have seen this in this country starting from maybe refrigerator to color TVs to four-wheelers to maybe smartphone, right? So if you are able to provide sustainable cooling, somehow get them onto sustainable cooling bandwagon, only then you have hope. And the only way to do that is to make it affordable. And the reason I say that affordable is that is sustainable today gets tagged by a premium and therefore gets restricted to the upper segment of the market. But with climate change, you cannot address climate change if only one segment of the market can afford it. It's everybody's problem, right? Climate change causes issues in Pakistan. One third of Pakistan is underwater right now. You have to make sustainable cooling affordable. Only then you can have everybody adopt it. Otherwise, people are going to adopt the cheapest option that is available, which may be inefficient. So our mission is to see that we provide sustainable cooling that is affordable so that we can get the mass market to adopt these technologies. And the key to that is we keep chipping at it, coming up with innovative solutions and not go with business as usual solutions and go back to your first principles and say, hey, why do we need to provide cooling? And the answer to that is because the heat is coming in from outside. So then the next question would, how do I stop it? And there you get your answer. The structure, remove it from the structure. It is coming through the structure. So flush it out from the structure.
Yeah, definitely. Right. You know, I was reading this book. It was called Resource Revolution, and it talked about two things. You either need to create new ways of harnessing resources, or you need to find ways to use resources more efficiently. So it's like doing on both sides. And like what you're saying, you're really looking, okay, how can we use our resources more efficiently and not just create like this new tech gadget or something like that, but create a system that's going to drastically reduce the temperatures and start working more efficiently, which I think is really great, because we really need to look at both sides in this resource revolution and for climate change, because not everybody's going to be able to afford that new green tech solution. But you need to find that sustainable solution that anybody can adopt, because it's either a behavioral change or you can easily implement it because it's cheap, because those are things that matter too. So I like how you mentioned that. That's great. So I'd love to hear a little bit about some of the other solutions that you provide. So do you mind talking a bit about each of your solutions that you work with and maybe an example that you've used with the client?
Sure. I'll not be able to cover all the solutions that we provide, but I'll definitely
No
talk
worries.
about the one that most excites me. We
Cool.
are working
Love that.
on a solution now where we want to use the wastewater for cooling. Now, a bit of a context there. Most of India is water stressed country. You look at the groundwater levels, you can see that how water stressed we are. So a lot of companies are moving away from water cooled systems to air cooled systems. Now, air cooled systems, they consume 30 to 44% more energy. Right? Now, a simple solution would be, how do we get water so that we can get that 30 to 40% energy saving straight away, right? Now, the problem that we realized is there is water. It's just that the sewage treatment designer doesn't talk to the HVAC designer. They both let one person wants water, other one person just leaves the water. So we have now systems that we are implementing where we reduce the cost of water treatment by segregating the solids from the water upfront. Your cost of treatment increases because the solids and water mix together, and that becomes really dirty water. But if you're somehow, and we use a partner's technology there, just to segregate solids upfront so that the water doesn't get contaminated as much. The solids get decomposed and gets composted, that can be used. But this water, now we use another technology from an institute here, which is a soil-based technology. It's a 2-decade-old technology. So all this reduces without chemicals, without too much fan aeration. So we bring down the cost of treatment 2/3. It's only 1/3 of the actual cost. So when you are able to do that, then you can say, hey, why not use this water for cooling now? So you have straight off the bat, you have water. You just start you're designing the system more intelligently so that you can use that water and get energy savings too. You're reusing water as well as saving energy. But what we are doing is going a step further. So typically in water-cooled systems, we evaporate the water. Still, there is a loss of water. What we are doing now is going a step further and creating a small pond or a lake, which becomes a sort of a water feature for that. And we use heaters. We put heaters in that water, which you cannot see. All you can see is a beautiful fountain or a lily pond. But we use that water body as a heat sink now to reject all the heat from that building into that by just using a pump. So you don't have to put pills in treating the water. You don't have to have energy for cooling towers. All you need is a pump connected to a piping network in the building, connected to a piping network in the water, so that you can keep flushing the heat to the water. And the water basically rejects that heat by radiation through the night sky. To me, this is the one that excites me more. There is a challenge of water, and there's a challenge of increasing adoption of cooling. And we're trying to address both solutions through one solution. So this is what excites me. This is going to be piloted in a few schools in India, and I'm hoping that this will be adopted widely.
That's awesome. That's great. And how did you guys come about with that solution?
Our first opportunity was actually where a school had a swimming pool, and we said, hey, why not use a swimming pool? Why put a chiller or an air conditioning equipment there? So we started with a swimming pool, but then we said, why not push it further? So that's how we ended up with creating an artificial pond or a small lake for water. But integrating this, our structure cooling solution with swimming pool was the first step there. But we figured not every place is going to have a swimming pool, but all places will have wastewater, and that wastewater to be treated, right? So that's how we moved on to the wastewater.
That's really cool. And so for the pipes that you're using to remove the heat like from the building and that you're going to have send out to the artificial pond or whatever, are they within the walls? Are you putting them under the floor, or where are they?
We typically install them in the slab, the great slab that when during the construction, but they can be installed in the floor screed too. The key thing there is to understand is wherever you put, the entire building is a single thermal mass. And we have seen this in our thermographic studies, that if the wall is, let's say, 35 degrees centigrade, the floor would be 30 degrees centigrade, even though the floor is not directly exposed to the sun or ambient temperature, because the wall is connected. So the heat transfer will happen through conduction. So the reverse of that would be, if I cool, the heat from the walls will flow to the floor or to the ceiling in the slab. It will flow wherever it is, right? Heat will always flow from hot to cold. So we usually avoid walls just because of construction issues. Somebody would nail something in that, or right. But otherwise, yes, walls would be ideal, but we usually do it in the slab.
Gotcha. Very cool. And so they go in the slab and then they go out to the artificial pond. And then where do the pipes travel after that? Do they come back, or are they going
Yes,
out
they come
to
back.
the treatment plant?
They go into the water pond, which is a treated water plant, treated water.
Got it.
And result of that, the treated water becomes a pond.
Gotcha. Cool. That's awesome. And when you said you're going to have a couple of schools demo this soon, do you have a timeline for when that's going to happen?
The swimming pool one is going to be operational next summer, and the wastewater one is going to be operational maybe 6 months down the line after that.
Gotcha. So summer 2023, and then 6 months after that. Very cool. And what led you to start Oorja Energy and Engineering? What led you to start the company? What was your motivation?
Okay, I would give some amount of credit to Michael Moore's Roger and Me. I don't know if you've seen that documentary. It talks about the blight of Flint, Michigan, how the decline of car industry led to the blight of Flint in Michigan. So that was a trigger, which led me to think about, I come from a very large coal town, and that led me to think about, at some point, the blight of a coal town is bound to happen. Right? You're going to run out of coal, or people are not going to use coal. One of these things will result in the blight of the town. And that led me towards studying renewables. I was working at Warner Brothers in LA at that time. And the more I studied about it, the more I felt that I need to be involved. And I moved back, but during this entire process, I realized that rather than renewables, where there are a lot of people working, I would rather focus on heating and cooling solutions and making them more sustainable, because more than 50% of the primary energy in the world is consumed for these two needs of humanity. We either need heating or cooling, not just spaces. I'm talking about industries. You need to produce and you would need heating or cooling. You want to manufacture beer, you need to ferment, you need heating, and then you need to chill it down, you need cooling. You take any product, more or less, you will find heating and cooling all areas, not just space cooling. So that was my motivation. And I'm a mechanical engineer, so decided to go back to my roots. So those were the reasons why I started looking at this field, and it took quite a bit of time to start questioning, because I was not feel it was when I took it up, I was at least a decade and a half out of touch with mechanical engineering. I had to go back and learn everything, and that was good because then I started questioning everything. Why is it this way, and not accept what was being done in the industry?
Yeah, that's great that you mentioned that too at the end with being out for a while and coming back. You're able to question a lot more because you have all these other experiences and things that you're able to bring in to this new look at mechanical engineering that you have some background in before, but now you're just like got new eyes. You've had different experiences. You can bring in some new creative ideas, which I think is always really needed. All different industries, just you bring in those new ideas to different places. So I think that's great. What are you into learning right now in terms of, are you into mechanical engineering stuff, or are you looking into more opportunities? What are you learning right now?
As far as mechanical engineering cooling, that's a continuous learning. But what I'm learning now to do is learning to have gratitude in my life. And one of the trigger for that is, so you have these thoughts of rapidly scaling up, but when you look at a lot of these companies that rapidly scale up, invariably I see a toxic work environment. Somehow they seem to go together, explosive growth and toxic work environment. There may be some exceptions. So one thing I'm very clear is that when we grow, I mean, it will be not an environment which has toxicity, but an environment that provides people to grow, enjoy. An organization, even a business organization, have to serve a societal purpose, right? And you can have the right thoughts and the right systems if you're aligned properly. And if I don't learn how to have gratitude for everything that people around me do, even though I may get the credit for it, right? How do I design my organization? How do I put systems that appreciate that, right? And not just look at people as numbers, productivity per head count or sales per head. It has to be beyond that. I think COVID did that to many, and maybe I'm one of you get a lot of time to think about what is that you're doing and how can you do that better. So it's been difficult because when you are somebody who is aggressive out there trying to do different things, you try to push people, but sometimes you need to take a step back and think, how can you do this in a better way, in a more humane way? And that's what I'm learning, just the initial step.
Yeah, and I think that's huge to be able to recognize that you're looking in a different way because, I've heard some coaches and different things that I watch talk about how culture is one of the main reasons that will completely destroy a company, but it's almost always the one thing that's overlooked by CEOs, especially those companies that are growing rapidly and have lots of growth happening. It's something that's overlooked. And it needs not be. It really needs to be the forefront, the center of business growth. And so I think that's really great that you're able to look at that because it's so important to really be able to make sure you're recognizing your employees and giving them the recognition they deserve and the gratitude and thankfulness for what they do because you're all in it together. You're all in it together to make a great business. So I think that's great. Yep. Yeah, definitely. And I'm just going to have a few more questions here. We'll wrap up for today. But what is one tip that you might give to another ecopreneur who is looking to grow their green business or start a green business?
This may be slightly have a context more towards where I'm doing business may or may not apply. One of the things that I've observed is many of the green entrepreneurs have the righteous attitude or a sense of that you are on the righteous path. Why is everybody not? Right. I think we need to start losing that, saying, okay, we are now on this path to provide or make planet green or something. Why are they not jumping? And I've seen a lot of people get frustrated with why are these people not adopting this? And I think my advice there would be to not take that path. It would be very dangerous to assume certain things about the market because you make wrong assumptions then about people. At the end of it, you have to provide something that people, your market, considers as value. That is. So if it is a green solution that you're providing, then you need to package it in a way that your customer understands it as a value, not you thinking that you are offering a value. I think looking at it from a point of view, especially those who are not converted or those who are not yet onto the green wagon. How do you bring them onto this? It many times may not be by invoking some sort of a guilt trip, or it's pure economic value. Can you deliver that pure economic value for your green solution or a green product? And there you have the answer. If you can think on those lines, I think you have your market and, of course, the growth.
Oh, definitely. I completely agree, because if you're just targeting the green market, you have those zealots who are going to be really excited about it and everything. That's great. But you're going to have to be able to talk to the other 60, 75% of people who are just going to be like, okay, I don't really care. And then, of course, you're going to have those 10% of people that you'll never convert, and they will be just completely hate everything you're doing. But you really got to be able to speak to that big, large chunk of the market that's just going to be impassive about it. Yeah, I could do it. I could not. Oh, so you really got to be able to speak to that too. And who would be kind of the perfect for you guys to partner with?
Oh, that would be a difficult question. There's so many people we
I'm
partner
sorry.
with, but what we do is we partner with a lot of architects and green building consultants. So basically, in the ecosystem, we go out and look who are doing the same work that we are trying to do, and why don't we multiply our forces, right? So when I look at our business, I see that whenever a new building is going to be built, they're not going to first come for a solution. They're going to go and talk to an architect, and then they're going to talk to somebody who's a consultant for a green building company, right? They would talk to them, right? So we go explain our solutions to them, make them understand, right? Because then they can be the neutral third party that advises the customer on, hey, this is what you can do, this is what is available, do you want it? Okay. Whereas if we try to sell it directly, we are an interested party, right? Our interest is only to sell, or that's at least the perception, right? So we work a lot with all constituents of all stakeholders who push those green buildings, especially in the initial phases when the customer is looking for the right solution. So architects, green building consultants, HVAC consultants, these are perfect partners with us, and they have given us a lot of work on the ground, and also always keep encouraging us to push the envelope.
Yeah, that's great. They also give you like feedback too, say, hey, this is what this customer said. And, hey, could you try this as well? Have you ever gotten any of that?
Yes, many of them. So it works both ways. They give us sometimes as to what is palatable to a customer, so that I tone it down, because at the end of it, you still need to get a solution out there. And then there are some customers for whom this is not enough, and they say, hey, why don't you push the boundary further? So they help us grow in that. Okay. And the examples that I gave you of that swimming pool and wastewater thing resulted from that, right? How can you make it even further? We are looking at it. Works both ways, and it's good to have them. They give us the right kind of feedback as to how to finally package our solutions the way the customer would see value, which is what I was talking about earlier. Right?
Yeah, definitely. That's great. And if anybody who would like to partner with you or is interested about learning more about what you guys do, how can they get in touch?
The best thing would be to go to our website, which is w.oorja.in, and you can leave us a message there, or you can also directly email me. My email address is madhu, madhu, at oorja, orja.in, and let us know what we can do for you.
Perfect. Great. Thank you so much, Madhu, for coming on this show. It's been really great and very enlightening to learn all about what you guys are doing and how you guys are really trying to transform that idea of, oh, do we really have to cool it down that much? Maybe we can create some more sustainable cooling options that are more attainable for India and other types of countries in the more closer to the equator. So thank you so much for coming on the show, and I hope to have you back on.
Thank you. Pleasure being on your show, and I look forward to connecting again. Thank you.
And if you enjoyed this interview with Oorja Energy and how they are creating sustainable solutions to help buildings reduce their energy costs so that we can meet our net zero goals, then I invite you to check out this interview with Nick Dimmock from Organic Heat Exchangers. They have a new product that allows them to reduce the amount of energy that it takes to cool a building by up to 80%. To hear exactly how they're able to achieve such amazing cooling efficiency, make sure you check out the full interview with Nick and Organic Heat Exchangers.